Let's go over the test, Unit 1 test that we had. So a ball is tossed straight up. Its height is given as negative 16t squared plus 30t plus 18. So the height as a function of time. So t is the time and h is the height. And the negative 16 is telling us there's two numbers that would appear here, either a negative 16 or negative 4.9. Negative 16 means we're doing it in English units, height in feet, time in seconds. A 4.9 would tell us that we were doing it height in meters and seconds. So this is the 16, so the time is in seconds, and the height is in feet because of the negative 16. Okay, now it says find the height at different times. I'll do this on a calculator. You can type in this equation with 0.5 in for the t's, but I like to type it in here. So I'm going to type in the negative, is that blurry there? No, that's good. Negative 16, I'll use x squared. If you use Desmos, you can type it in there with t or x. And plus 30x plus 18. And I want to show you the easy way to do this. If I go to table set, second, the table set's in blue, click there, and go to ask on the independent variable, then I can go to second table, and I can put in the times I'm interested in. So if I was interested in 0.5, I'd go 0.5, and it tells me it's at 29 feet. Height is feet, so it's 29, half a second, it's at 29 feet. And I wanted units. And at 1.1, so I'll type in 1.1, and it tells me it's at 31.64 feet. And that's rounded off, but close enough. Then I have to decide what will make 25. Well, I could sit here and guess, but I can also go to, and you can do this on Desmos also, I can write y equals 25. And then if I graph on a calculator, I can go zoom 6, and this object went up and then came down. So it's off my screen, so I need to look higher. So I'm going to push my window button and go make my Y height higher. I'm going to make it maybe 30 feet, see if it gets that high. So now I'll graph. Well, went a little higher than 30, but there's the 25, and going up, this is time passing, and so the object is going up, and at some time it hits 25, and then back on the way down it hits 25. So I need those intersection points. To do that, on the calculator, you push second, calculate the intersect. Oop, I didn't do that. Second, calculate the intersect. And it'll ask me, is this one of your curves? Is this the first curve, this blue one? And I'll press enter to say yes. Then it jumps to the red graph. I can know it's on the red because it's in red. Is that the second graph that we're looking for an intersection with? And I press enter for yes. And then it says, give me a guess. I'll put my cursor close to where it is and then press enter, and it says 0.27 seconds. Now there's another intersection over there, and that's why they have that. So if I go start again, second, calculate the intersect, and it's asking me again, do we want to look at the blue curve? Enter. The red curve, yes, enter again. And then I got to get close to the other one or it'll just give me that same answer. So my guess will be about there. Press enter, and it says, oh, that one's 1.601 or 1.602, 1.6 seconds. That's when the object will be at a height will be 25 if I put 0.27 into the equation. If we go back to the table just to check, we can put in 0.27 and we should get close to 25, 24.9. And we should be able to put in 1.6 and it gives me close to 25. So those are good approximations of the height. Now you could do that same thing with the quadratic formula, setting this all equal to 25, but that's a lot of work. And what are the meaning? 0.27 seconds is the time the object reaches 25 feet on the way up, and the 1.6 seconds is the time when the object reaches 20 feet on the way down. You can write that shorter, but I want you to know that one of those is for the height that's 25 on the way up, and the time for when the object's on the way down. Now, this minus this would be just this answer minus this answer. But what does it mean? Well, this is the height at 1.1 seconds. This is the height at half a second. So if we find out the height at the end minus the beginning, we're finding out how much the change in height between 0.5 seconds and 1.1 seconds. Okay? All right, number 2. So here's a graph. This is in minutes. You have to watch your units on this. And the vertical axis is in miles per hour. And the horizontal line is for a blue car. And the red car is the horizontal line. Red is horizontal. And this is the blue. So this says determine the velocity at 25 minutes. V, this is the velocity graph, and this is the time. So at time 25, what's the velocity for the blue car? So there's 0, 10, 20, 30. So 25 would be here. And we go up, and it's going about 40 miles per hour. Okay. Acceleration is how the speed is changing. If you accelerate in a car, your speed picks up. If you decelerate, that's negative acceleration, you're slowing down, generally. So, if the velocity is staying the same all the time, there's no acceleration. If it's increasing, there's acceleration. The red car, determine the acceleration of the red car. Well, if it's going up, it would be the slope. And so we'd figure out the slope of this line by picking 2 points, maybe, and doing the change in y divided by the change in x. But it's the red car. And the change in y, it's going up 0 miles per hour for any minute, second, hour. So you could put down anything, but the units here are minutes, so Kind of expected that, since 0 doesn't matter what you put on the bottom, as long as it's not 0. So the answer is 0 miles per hour for every minute, or miles per hour for every hour. It's still 0. Determine how far the red car, the distance for the red car in 20 minutes. Well, the red car is going 50 miles per hour for 20 minutes. So 50 miles in 1 hour, and we're going to go for 20 minutes. Well, that doesn't match in units, but 20 minutes is 20 out of 60, or 1/3 of an hour. Or if you want to think of it, 20 minutes 3 times makes an hour, so 20 minutes is 1/3 hours, and the hours would cancel, and we're going to get the distance, which I asked for, miles, and it's going to be 50 divided by 3, which is 18 and something, I think. Let's see here, 18. Clear. 50 divided by 3. 16 2/3. You could have done 16.66 or 16.67 or 16.7, something like that. Something close that I know how you did it, and I want to see your work. Okay, most everybody missed D. Both cars are at the same place at 60 minutes. 60 minutes. At 60 minutes, they're the same place. Which car is going faster at 60 minutes? Well, the blue car is. It's got a higher speed. So the blue car is passing the red car because it's going faster than the red car. And so the blue car is finally passing the red car. So if both cars are at the same place at 60 minutes and traveling in the same direction, which car was ahead before? Well, if both cars are at the same place at 60 minutes, both cars are at the same place at 60 minutes. I've got to think about this here and make sure I say this right. At 60 minutes, they're both here. And the blue car, most of the time, was going slower. It finally got faster later, but it was going slower. It was going slower most of the time. It started catching up in speed. The red car was going faster. So if the red car was going faster than the blue car, most of the time, the blue car had to be ahead of the red car up until real close to the end there. When the blue car finally caught up in speed, it would start passing it. But since the red car would, saying this wrong, the blue car was going slower, so it had to be in front of the red car if they end up at the same place. If the red car is going faster than the blue car had to be ahead of the red car at the start because the blue car is catching up with it. Here it changes, but for most of the time the red car is going faster, so the blue car had to be ahead. Okay. Seems like a simple question. It seems like you should know how to read a ruler, and a lot of people struggle with this one. And that's because they count tick marks instead of spaces. When you use a ruler, you're saying there's some distance there, there's some distance there. And if you count each little space, let's see, there's 4 spaces here. 1, 2, 3, 4 in that 1/4 inch. 1, 2, 3, 4 to get to here. Another 4 to there, another 4 to there, another 4 to there. So there's, here's the 2-inch mark. So there's 4 from there, 4 there, 4 there, 4 there, 4 there, 4 there, 4 there, and 3 more spaces here. 1, 2, 3, 4, 5, 6, 7 fours is 28, 29, 30 spaces, 31 spaces. 31, and each of these little spaces is, well, for a whole inch, there's 16 of them, so each space must be 1/16 of an inch. So that's how long this line is, 31/16. Now you could change that to 1 15/16 if you wanted. 32/16 would be 2 inches, but this is a little shorter. Okay. If we have a box that's 5 inches by 9 inches, and you're folding up some on this side and some on this side and some on this side and some on this side to make a box like we did in class, and the amount you're folding up is 11/16 of an inch, then the 5 in width would lose 2 of these 11/16 of an inch. The length, which was 9, would also lose 11/16 twice. And these would both be in inches, because this was in inches and this is in inches. And the height, well, the amount you fold up will determine the height, and that's 11/16. And you can type this in like this, but to figure out the volume, but I'm going to do it on my calculator to save me some time, because what I'm doing is 9 minus 2 times whatever this is, and that's how I'm getting the volume, and I'm taking the length times the width, which is going to be 5 minus 2 times whatever I put in for x, and then times the height, which is x. So I'm going to type that in to my calculator or into Desmos. So clear 9, parenthesis 9 minus 2x, close parenthesis, open parentheses, 5 minus 2x, close parenthesis, and times an x. And get rid of this one and go to, since I've got it set on independent, I can go to table, I can delete these, and I can put in whatever I want for the height. And I wanted for the x to be 11/16. So I can go 11 divided by 16, and it says the volume is 19.003 cubic inches, because volume's in cubic, and this would have been in inches. So I got units, 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 units. This would be the volume in general, depending on whatever x is made. And now I want to find out what makes the max. Well, since I typed this equation in, I can just graph it. And the volume goes up, and then it comes down, and it goes up. And there's an x-intercept, an x-intercept, and an x-intercept. And it looks like the max is here, because I can't fold up these big sizes or negative sides. So there's a number in here for x, for the amount that I fold up, gives me a max. Now, if this is Desmos, I could just tap on the point. And on some of the graphing calculators, you can, but on this one, you can't. So I use calculate, second, calculate the maximum for. Now, if there were several maximums, I'd want to find just one that's between a couple places, because I don't know it exactly. So what the calculator says, find two numbers that it's between. Well, 0 is a good spot, so I can say it's between 0 and 2. And my guess is it's probably at about 1. So I'm going to push 1. And the calculator say, no, you silly, it's 1.03. That's how much we should fold up. A little bit more than an inch. 11/16 was less. And I should get a higher volume. And the volume should come out to be 21.02. cubic inches. So you can see the maximum, the X value gives the maximum and what the maximum value is. Okay? Now there are 3 x-intercepts. There's one there, there's one there, and one there. Now on a calculator, they're called zeros. And it'll ask you, do you want the 0 between these two places? Well, I'm more interested in that one. That's between 2 and 3. So I can say it's between 2 and 3, and I think it's 2.5. And it says, oh, you are so good, it is 2.5. So anyway, there's an x-intercept at 0 on the x, at 2.5, and at 4.5. 0, x at 2.5, and x at 4.5 inches. And 0 is saying we're not folding any height up, so there'd be no volume because no height. That's the meaning of that intercept. There's no height. If you fold up 2.5 on this side and 2.5 on this side, and the thing is 5, you wouldn't leave any width. So there would be no width, therefore no volume. The width is 0, and it's length times width times height. Multiplying by 0 is 0. And 4.5 would be folding up 4.5 on this side, 4.5, and there would be no length. So therefore, no volume, because that would be a 0 length times width times height to be 0. The domain. Well, you can see the domain, the only place that makes sense is to fold something up between 0 and 2.5. So that's what we write for the domain. Something between 0 and 2.5 makes sense in this problem. And our answers we get are something from 0 up to the top, which was 21.02. 0 to 21.02 cubic inches. But the amount you get out is somewhere between 0 and 21.02. And the heights you fold up are somewhere between 0 and 2.5. That's the domain for this situation, and the range for this situation. Range is the y values you get. Domain is the x values. Okay, number 5. So, we got a vase here that's pretty small on the bottom, gets bigger and bigger up to here, and then it stays the same size. So if you're pouring water in at a constant rate, and I'm keeping track of the height, so I'm starting down at the bottom of the vase and I'm working to the top. When I start pouring water in, like if I stick this vase under the faucet, this part will fill up faster than up here because it's smaller. So it's going to go pretty fast at the beginning, and then it's going to slow down when it gets to here. And don't make a bend, because this is how fast it's going up. The speed it's going up right near this bend is going to be the same the rest of it. So the slope has to be the same, because the slope is how fast it's filling up. As time goes by, the height will increase constantly for this part. It goes up pretty fast at the beginning and then slows down a bit and stays at that rate. Now here it's wider at the bottom, so it's going to start off slower, and then as it gets narrower, it will start going faster, and when it gets to this bend, it'll stay going whatever it was right before it. It'll stay going at that rate, so it'll be straight for the rest of it. After it gets to this height, it's picking at speed, it'll stay at the same speed. Now this one, it's similar on the bottom and the top, so the slope has to be similar at the bottom, at the beginning and the end. And it's small here, so it's going to go up pretty quickly, and then it's going to slow down through this part because it's fatter in here. And then as it works its way up, it's going to speed up again and be about the same slope here as the beginning. That's a lot of reasoning, but I'm hoping you start thinking in those terms. Okay, this is miles per gallon. 45 miles per gallon. So if I multiplied by the number of gallons, the gallons would cancel and I'd get a distance. So distance from the gallons, I would take, since it's getting 45 miles per gallon, I would take it times the number of gallons. So now I have a function that has g in it, takes in gallons, and returns the distance. I want one that takes in time and gives me the distance. Well, the speed is in 55 miles per hour. So if I do time in hours, the number of hours, then take it times the 55, the hours would cancel and I get distance. So this has to be 55 times the number of hours. And I said use t, so you have to put t. So now if I just leave this thing saying d is a function of t, that you have to give it t and it'll give me d. If I write this as d equals 55t and divide by 55, I can find that t is d divided by 55. So if I want to get t from d, the variable will be d, and I'll divide it by 55, and I will get the t, which is what I'm supposed to get out, the t. And similarly, d equals 45g, so g equals d divided by 45 to get the 45 off of there. So it's going to be d divided by 45, the distance it goes, divided by the miles per gallon, will give you the number of gallons. Now this one's the tricky one. We have to start with g. This one starts with t, this one starts with d, this one starts with g, and this is the only one that starts with g. And it gives me d. So if I do 45g, this is another expression for d. But I want to get t. Can I use d at t? How do I use t to get d? How do I use d to get t, and I want to get t from d. So whatever d is, remember this was d, I have to divide d by 55, and that will reduce a t. So that's that part. 7. The two things you got to watch out for are even roots, like square roots, or fourth roots, or sixth roots, not cube roots or fifth roots, being negative. No negatives. Don't be a negative thing underneath. Or division by 0. There's no division here, but there is a square root. So the 2x minus 6 can't be negative. Now, I'm going to set that equal to 0 because if it's 0, it's right on the borderline between positive and negative. If I add 6 to both sides, I get 2x equals 6 divided by 2x equals 3. 3 is the dividing line. If I put 3 in there, 2 times 3 is 6, minus 6 is 0. You can do the square root of 0. If I put 1 in there, I get 2 times 1 minus 6. Oh, that'd be 2 minus 6. That's negative. I can't use 1. That's on the low side of 3. So I don't want to use numbers lower than 3. How about bigger, like 4? 2 times 4 is 8 minus 6. That's positive. That works. So I need to be 3 or bigger. 3 or larger will work in this. Now, I'll just say that if it was 6 minus 2x, then I wouldn't want to use larger, like 4 in here. 6 minus 8 would be negative. I'd have to use smaller. But this one requires 3 or bigger. This one has no square root, so I don't have to worry about being negative under a root, but it does have the possibility of being divided by 0. If x was negative 6, this would be a problem. So x can be anything except negative 6. Or if you want in interval notation, negative infinity up to negative 6, not including it, union, not including negative 6, but on up to positive infinity. Either one of these answers would be fine. And there's other ways to write it. Now here we have a square root. So the only thing under it's an x, so it has to be, x has to be 0 or greater, just for the numerator, 0 or bigger. But the denominator is x squared minus 1. And if you think about it, if I put 1 in there, 1 squared minus 1 would be 0. So I can't use 1. And negative 1 squared would be 1. And that wouldn't work either, so I can't use negative 1. So it has to be 0 or greater, and it can't be either of those numbers. I think that means then that we can be anything from 0 up to 1. Can't use that negative side, so we're out of there. Union, and then we can be from 1 to infinity. That's what will work in here. Now, you can type these into Desmos, and the graph will show up in places, and for whatever x's it shows up as, it should be from 0 to 1, you should see a graph, and from 1 to infinity. Let me just type this one into the calculator. See, you won't be able to tell if 1 is or is not, but I'll type this one in just so you can see it. I'll clear this and type in the square root of x, come out of the square root, divided by, and I better put this in parentheses because it's divided by all of it, x squared minus 1, close parenthesis. And if I push graph, do you see how, let's go to Zoom 6. It shows up, the graph shows up from 0 up to about 1, and then it just disappears. It avoids it on this side and avoids it on this side, but then after 1, the graph shows up again. So it's indicating that we can go from 0 to 1, but not 1, and then from beyond 1 we can use. That's how you can check yourself with a graph. Now this one, so x has to, whatever we use has to work in f. And we've already determined that has to be from 3 to infinity. Now some of those may not work if the numbers we get out of there using these numbers have to go into r. And r can't use negative 6. So what could we put into for x that would cause this to be negative 6? So that's where we have to sit down and say, okay, 2x minus 6 minus 10 cannot be negative 6. We don't want an x that'll make this be negative 6. So we'll see if this is any numbers in the area from 3 to infinity. And if it is, we have to throw those out. So if you add 10 to both sides, you get 4 equals the square root of 2x minus 6. To get rid of a square, we square root, we square. So we get 2x minus 6 equals 16. Add 6 to both sides, and we get 2x equals 22. Divide by 2, and x equals 11. 11 times 2 is 22, minus 6 is 16, square root of 16 is 4, minus 10 is negative 6. So we can't use 11. We had to be, to go into f, it had to be 3 to infinity. But of those, we can't use 11. So this gets modified to, we can go from 3 to 11, not including that, union 11 to anything bigger. So it was this, except that we had to exclude the 11. Okay, last one. Again, we're going to go into R, so we can't have a negative 6 again. And this is what we're putting in. Well, what would make this be negative 6? Because there's no function here. It's just numbers we're putting in for x. Well, if x was negative 3, then negative 3 minus 3 would be negative 6. And we can't use that in R. So x cannot be negative 3. This will take anything else. This will take anything else. So our answer is going to be any number except negative 3. Or you could say all reals except negative 3. Okay, one last page. All right, let's do these carefully because I keep doing them too fast and mess up. I'm supposed to put 1 into f. So that's going to be 4 times 1 minus 5. 4 minus 5 is minus 1. So I'll have h of f of 1 is minus 1. So now I got to find out if the input is minus 1, what does h give me? Oh, 2. This one says when there's addition or subtraction, that means you put the minus 2 in, or multiplication or division, you put the minus 2 into both of these and add the answers. So what is k of minus 2? Another way to write this would be k of minus 2 plus g of minus 2. K of negative 2. Now, k was this graph. Minus 2 gives me 2. G of minus 2 gives me 1. So 2 plus 1 is 3. Now it says, what number would I put in for x? What number would I use here to get out a minus 2? Well, here's the minus 2 I would be getting out, and it looks like I have to put in 6 to get minus 2. So x would have to be 6 for k of 6 to be minus 2. So that's my answer for x. Now this says we got to do 3 things here. First, we got to put minus 1 into h. So minus 1 into h is 2. So I'm changing this to a 2. So I'd have k of f of 2. So now I have to put 2 into f. So that would be 4 times 2 minus 5. So that's 8 minus 5, which is 3. So this is 3. So I'm doing k of 3. So I'm going to look over here, k, and when x is 3, the y, what I get out, is minus 1/2, approximately. Now, f, going forward, it takes the x, multiplies by 4, subtracts 5 to get to y. I want to reverse this process. And so in class, we said change the f of x to y, then reverse the process by calling it x instead of y equals 4y minus 5, and solve for the y, and whatever we get will be f inverse. So to solve for this, I have to add 5 to both sides. So I get x plus 5 equals 4y. And then that's times 4, so I divide by 4 this whole side. And so I get y is equal to this, which is what the inverse would be, x plus 5 over 4. Okay? G inverse. G takes these numbers and changes them to these. The inverse, these would be the x's, and these would be the G inverses. So I would just switch those two columns. Call this x, call this G inverse, put these numbers in this row and these numbers in that row. However, if these are in the x's, I have one going to many different answers. I have a non-inversible thing, so there's no inverse here. If you were to graph x and g of x, graph the point -2, 1, and you graphed 2, 1, it wouldn't pass the horizontal line test. It would hit in 2 places. To have an inverse, it has to be 1 to 1, pass the vertical line test and the horizontal. Now h, if you look at h, if we put these as the x's, there's no repeats, and there's no repeats here, so that's 1 to 1, so we can do h inverse. So I'm going to put the numbers of h as the x's. The numbers that h has for x's are 3, 2, 1, 0, minus 1, and these are the only points we know about, so we're not trying to make any equations. We're just going to write this backwards, and what's taking it back, the inverse, will go back to the x's, and the x's were -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. There's a table of all the h inverse points. 3 would go to -2, 2 would go to -1. Instead of -1 going to 2, it's going backwards. All right, and finally, this says do k backwards. So 3 is not the x, it's the y, and we got to figure out the x. So 3 is the y, and the x had to be -4. So k of -4 is 3. So k inverse of 3 is -4. It's working it backwards. So this becomes f of -4. Now we put -4 into f, which we multiply by 4 and then subtract 5. So we take 4 times the x and subtract 5, and we get -16 minus 5, which is -21. Okay. This one Wasn't a great one for the test because it kind of lands on top of itself in a bunch of places. But just like we were doing here, we're reversing roles. So this point, -2, 9, goes to 9, -2. This point gets moved over to here when we do the inverse. It's a straight line between there, and that point is 1, 2. So that will go to 2, 1. There was a straight line between those, so there's a straight line between these. Okay. And it looks like it's little over 3, 0. So we'd go to 0, little over 3. Now, this curve is a little hard to tell. It goes off at an angle, and that might be a little confusing. But this line, it flows right into the curve. So I'm going to finish this. This point and this point have a straight line. So this one looks like about 5, -10. So I'm going to go to -10, 5, and draw a straight line for this. This is where this line goes to. And then it flows right off that and curves to hit the other end. So I have to go straight off this and curve to hit the other end. And so that's the inverse of this black line is this pencil line. Okay.